The greatest trick the devil ever pulled was convincing the world he didn't exist. That was his power.
Are you hypnotized right now? Be honest.
No, I'm awake.
You're awake. Totally awake. Are you hypnotized, ma'am? You guess so? Okay. Are you hypnotized?
No.
You are not hypnotized. Are you hypnotized?
No.
No. Your name, ma'am?
Patty.
Your name, sir?
Mary.
Your name is?
Mary.
Your name is?
Patty.
Your name is?
Bob.
Your name is?
Bob.
Could I see your name tag just a second, if you don't mind? It says Karen. What's your name?
Bob.
Are you positive?
Yes.
Are you positive your name is Mary?
Yes.
Are you a betting person? I got a bet you might be interested in. I'm willing to bet you $500 that your name is actually Paul, not Mary. I'll bet you $500 your name is Paul. Would you take that bet?
No.
What's your name?
Mary.
I'll bet it's Paul. Would you bet $500 it's Mary?
Yeah.
Would you shake on that? Before you shake. How many people in this room think his name is Paul? Can I see by show of hands? See all those hands up there? You know? How many people think his name is Mary? See up.
واستفزز من استطعت منهم بصوتك وأجلب عليهم بخيلك ورجلك وشاركهم في الأموال والأولاد وعدهم وما يعدهم الشيطان إلا غرورا إن عبادي ليس لك عليهم سلطان وكفى بربك وكيلا.
Your brain, the most complex organ in your body, the seat of who we are, what we are, the container for our thoughts and our memories. In short, we are our brains. Our brains are built from many parts that perform different functions. Deep in the centre of the brain is the brainstem. This is the oldest part of the brain and has also been called the reptilian brain. It controls many essential functions such as breathing and heart rate or blood pressure. It's whether we feel hungry or thirsty. It's also the seat of our most fundamental emotions, happiness or sadness, fear and love or hate. They all seem to reside in the brainstem. The occipital lobe contains the visual cortex, and so is concerned mainly with vision. The parietal lobe is concerned with processing sensory information and integrating it with the visual information from the occipital lobe. The temporal lobe is the centre for memory and learning. It contains the hippocampus and a number of other regions that are required for us to recognise different objects, faces, sounds and environments. The frontal lobe is probably the most important part of the brain for defining us as who we are. It's where our higher emotions and personality reside, as well as language and social behaviour, lots of the things that we think of as being who. It's our decision-making centre and contains the motor cortex, which controls voluntary movement. At the back of the brain are the two lobes of the cerebellum. This region of the brain is a coordinating centre for movement, allowing us to move multiple sets of muscles in a coordinated fashion so that we can walk and talk, pick things up and put things down. Your brain is made up of billions upon billions of cells called neurons. These cells are very specialised, with long extensions through which they talk to each other and form large and complex networks. These networks are the basis of how the brain does what it does. The processes are of two basic types. Dendrites receive incoming information from other neurons. Signals pass through the cell body or soma, where, if sufficient information is received, a signal is passed to the other neurons via the axon. This is happening in billions of neurons across the brain 24 hours a day, 7 days a week. It's happening right now while you're watching this. So how do neurons talk to each other? Neurons are usually seen to use electrical signals to communicate. However, the act of passing the signal from one neuron to another is actually a chemical process. This happens at structures called synapses. These are formed from the terminal of an axon and a swelling on the dendrite called a spine. Electrical signals from the axon pass to the dendrite via a chemical messenger called a neurotransmitter. Neurotransmitter is stored in the small vesicles inside the axon terminal, or the presynaptic bouton. When a signal arrives down the axon, one or more of these vesicles joins with the outer membrane of the bouton and releases its contents into a small gap between the axon and dendrite. This is the synaptic cleft. On the other side of the synaptic cleft are receptor molecules to which the transmitter binds in much the same way as a key fits into a lock. The receptor molecules act as pores through the outer membrane of the dendritic spine, allowing charged atoms or ions to cross. This entry of charged ions into the spine recreates the signal that was sent from the previous neuron, and in this way information can be passed from one neuron to the next and around the neuronal network. Although we've seen only one neuron here talking to one other neuron, in reality each neuron talks to many others and can have thousands upon thousands of spines. In this way, an extraordinarily complex system can be built that allows us to see, hear, to experience the world around us. It allows us to walk and talk, and to laugh and cry, and to be who we are. So we really are our brain.